Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Show that the function f of x equals x cube minus 1 divided by x minus 1 for x not equal to 1 and f of x equals 3 for x equal to 1 is continuous on minus infinity to plus infinity, right? So from the equation of f of x, it's very evident that the point of concern is x equals 1, and for x greater than 1, so let's, and for x lesser than 1, we don't seem to have a challenge, right? So let's divide it into three parts. What is your part 1, which is your minus infinity? Let's pull this out. Our minus infinity to 1 in the open interval. Okay, and I'm gonna write that as like this. Consider f of x in this interval, right? f of x, f of x for x belonging to, right? And how do we go about writing the equation for that? And we have x cubed minus 1 divided by x minus 1, right? So that's our equation. So this is going to be our f of x, right? And what is x cubed minus 1, folks? X cubed minus 1 is x cubed minus 1 cube, right? And what is that? That's nothing but it's further, when I expand this, I can write it as x minus 1 into a square plus b square plus ab, right? So I can call this out as x square plus x plus 1 divided by x minus 1, right? And I know my x square, x minus 1 and x minus 1 gets cancelled. So I can comfortably say that this equation is x square plus x plus 1, right? And let's move to the next line. I can call this as x square plus x plus 1. And what is this? This is a polynomial of degree 2. And I don't think we'll have to go into the detail in establishing the continuity. We know that any polynomial function of this format is continuous. And so we can straight away call this out as f of x continuous in this interval, right? F of x is continuous in this interval, right? So now let's move to the next interval. And I'm not gonna spend too much time on this interval, and I will explain that to you why. We will have to consider the interval 1 to infinity now, right? Which is x greater than 1 and includes, does not include 1, but is up to infinity. It belongs to the set of real numbers without including 1 but greater than 1, and that is what we are going to work this out for. So we still have the same equation, right? So the equation does not change, so we can just copy what we did in our previous step. And I know that this is a polynomial function again, and I have this continuous in the interval 1 to infinity as well, right? So let's just copy this open interval 1 to infinity. This particular function is continuous, right? So the point of concern, which is going to be our part 3, because we've been asked to establish, prove that this function is continuous at all points in the open interval minus infinity to plus infinity, right? For x equals 1, right? So what is my f of x at x equals 1, right? My f of x at x equals 1, I go back and I see that I have been given a value. Let me highlight this in yellow, sorry, in yellow. which is 3, right? So my f of x at x equals 1 is 3. And now I'll have to figure out as we move from x equals 1 from the left to the right, uh, we will have to figure out what is our f of 1 minus and what is our f of 1 plus, right? When I say 1 minus and 1 plus, you know what I'm referring to. I'm referring to the calculation of the left hand limits and the right hand limits, right? So let's write that down. Let me call it LHL comma RHL. Let's write it down and then establish what LHL and RHL is, right? Before we conclude that they both are going to be equal. So my function f of x for a value which is very close to 1, be it from the right hand side or the left hand side, is the same, right? So it is for that reason we know that my x tending to 1, x cube minus 1 divided by x minus 1, my LHL and RHL will be equal, right? Because I have f of x as x cube minus 1 divided by x minus 1 for my LHL and RHL. And what is this? I know that my x minus 1 will get cancelled out. So I can write it like this, and I have it as x square plus x plus 1, right? So as x tends to 1, I have my x square is 1, my x is 1 plus 1, which is equal to 3, right? So at x tending to 1, I have that my left hand limit and my right hand limit both are equal, which means that this particular function has a finite limit as x tends to 1, and that is also equal to f of x equal to 1, also equal to my limit x tending to 1, right? So let's write that down. 1 f of x, right? And this therefore continuous at x equal to 1, right? So we've established all the points x equal to 1, x open interval 1 to infinity, and x open interval minus infinity to 1. Therefore, uh, combining the three parts, we know the function is us at the open interval minus infinity to plus infinity, right? I'm just going to copy this, folks. Right. So that solves the problem. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.